This video session will be discussed about how to create a machine learning case study and step-by-step explanation. Here, we create a machine learning case study using the topic customer zero prediction. First of all, creating a machine learning case study, we import or upload the dataset using this upload method. This is a dataset, customer zero prediction, bank. This is a bank customer zero prediction case study. This is a CSV file, same modeling of CSV. And then we give some title name for this case study. After all this, we give some brief introduction for this case study. Here, in this case study, we aim to accomplish the following for this study. First one, identify and visualize each factors related to customer service. The second one, build a prediction model that will perform the following. Is classify if a customer is going to churn or not, or preferably and based on model performance, choose a model that will attach a probability to the churn to make it easier for customer service to target more handling force in their efforts to prevent churn. Here, these are dataset windows or number, customer ID, surname, credit history, geographic, gender, age, tenure, balance, number of products, as credit cards, these active numbers, and assume the salary and excite graph. This section, we will seek to explore the structure of our data to understand the input space the data set and to prepare the sets for exploratory and prediction tasks as this one. Here, step one, that is import the key libraries. Here we use NumPy patterns, whereas network by plot is created models and resource. And then step two, that is read the data set using this function. This is a data set A, language if, equal to period.read underscore CSV. This is a data set A. This is another data set. And we check the shape also. This is the shape of this data set. 1014. Then the step three, that is the basic data view exploration. Here is find the information of this data set, which we start in the full structure. These are the information of this data set. After finding this information, we could understand that here is no missing and assist in this data set. Here, the all values are 10,000. There is no missing and assist in this data set. And then we can first find rows of this data set using these dot header functions. And then we check the data types of this data set using this dot d types functions. Here, there is major object, floating point, etc. Here, so we mostly can categorize variables and five continuous variables. These are five continuous variables: object, object, floating point, floating point. 1, 2, 3, 4, 5. These are the five continuous variables. These are categorical variables. And then we print the 10 samples of this dataset using this dot sample of function. These are the 10 samples of this dataset. And then we print the column names of this dataset. These are the column names: row number, customer ID, surname, date, score, geography, gender, age, general balance, number of products, credit cards, these active numbers, simple salary, and etc. And we check the missing values exist using this function. is a function, but is not a subway function. Here, there is a missing analysis, and then we convert the string values yes and no to numerical values 1 and 0 using this function. Yes and no, the string values yes and no to convert the numerical values 1 and 0. Yes is 1, no and 0. Here we find the percentage of missing values using this function. Here 1 or 0 because there is no missing value exists. So percentage are 0. We find duplicates using the function and we print the unique values of this data set using this function and unique function using the unique values. And then step 4, that is data preprocessing of clean here. Machine and is not read here. And we drop the unwanted here. From the above, we will not require the positive attributes that are specific to the step up. It is borderline if the submine has is result to profiling. So we exclude this as well. Here, we drop the column as explained above. These are the dropping columns, amount numbers, and summary using this function, drop function. Then we check the left column names. These are what column names. And then we find the distributed statistics using this historical function. Here we calculate mean, median, standard deviation, etc. Here we count the mean, standard deviation, minimum, Q1, Q2, Q3, maximum, etc. Of course, columns separately. And then we set the categorical variables using this function. These are the categorical variables. And we find the numerical variables using this function. These are numerical variables. Here, we check the frequency of classes of different variables using these excited columns. These are the dependent variables. Here, in this churn means customer leaving the bank, and no churn is customer who did not leave the bank. So the category variables are section. We check the frequency of non-churn group according to tenure. These are the category variable tenure. Using this function, we check the frequency of non-churn group according to tenure. And we check the frequency of churn group according to tenure. Using this function. The second, next, the number of products. Here, we check the frequency of non-churn group according to number of products. Using this function, third function. And we check the frequency of churn group according to number of products. Then this is not churn, this is churn, using the number of products. And next, cash credit cards, using not churn, and churn. Here, we examining the cash credit cards of the not churn and cash credit cards of the churn lips. Separately, we have values. And next, we use is active numbers to examine the is active numbers of the non-churn group and examine the is active numbers of the churn group separately using this function. Next one, geography, gender. Step 5, that is EDA, exploratory data analysis. So we conduct exploratory data analysis, understand that is structure and identify key patterns and correlations. Here, Our main interest is to get an understanding as to how the given attributes related to its exit status. Okay. Here we create a pie chart using the function. The readings are proportions of custom children and intent, excited and retained. Here, about this pie chart, 20% of the customers have children. So the baseline model could be to predict that 20% of the customers will churn, given 20% is a small number. We need to ensure that the chosen model does predict with great accuracy is 20% as it is of interest to the band to identify and keep these bunches supposed accurately predicting the customers that are voltage. Next, we create a counterplots. Here we first review the status relation with category variables. These are category variables. Here we note following. Majority of the data is from persons from France. Geography. Majority of France. However, the proportion of genuine customer is with inversely related to the population of customers, alluding to the bank possibly having a problem. Customers will use the resources allocated in the area where next few clients. The proportion of female customers journey is also greater than that of male customers. Females are male customers. Interestingly, majority of the customers that tuned are those with credit cards. Given the majority of the customers have credit cards, majority of the credit cards, to prove this to be just a coincidence. And unsurprisingly, the inactive members face a greater change. These are inactive members. Picture. Worryingly is that the overall proportion of inactive members is quite high, suggesting that the bank may need a program implemented to ensure these group active customers as this will definitely have a positive impact on the customer journey. Here we created a workbox. Here we are relations based on the continuous data attributes. Excited. Right? These are X values, excited and Y values were stored. Here Y value is gender. Here Y value is age. Here Y value is parents. Here we come to create a convert using the toolbar palette. Here the X value is geography. It is France, Spain, and Germany. Y value is scout. Here the orange one is females. The blue one is male. It's a fire. And the whole geography wise, males and females are level. Next, support recognition model. SVC model using this function, linear function. Next, outliers here using the function to determine the threshold values for outliers. And here, there are many outliers in the variation. It is using the function as outliers. This variable. Here, after all these operations, here there is no outliers. Here, there is has no outliers, agent has no outliers, balance has no outliers, scenario has no here there is no outlier exists. Next, one hot category. Here, the variables to apply one hot category is here we create a list, gender and geography. This is a the data set name, then new variables. Here the dummy list, and we bring the first file also, which is data set. Then we see a dummy variables created, and then the scale fusion using statistics that are robust to outliers. This is a function that is the scalar. We create a new column, gender male, geography Germany, and geography Spain. We will check. That's it. Yeah. Gender male, geography Germany, and geography Spain. And we check the column names. Here we create more column names within those functions. Here, gender male, geography Germany, geography Spain. Here we invoke the fit vectorizer using this function. Here we draw customer ID column using the function. When we print that data set, here there is no customer ID exists. Drop it. Here we convert next we convert customer convert churn to binary. Yes, equal to 1 and no equal to 0. Using that function. This is a for a name credit step. Here we separate features and other variables using the function. Here we invert the vectorizer and then we check the sample text data and create a rapid vectorization and fit and transform the data using the function. Fit and transform. Then we print the shape. These are the shapes. 2, 7. Here, which is the shape and length. Right? That's right. Here, using the function to split the train and testing data, and then we create a random forest classifier function using these functions. This is a random forest classifier. And then we evaluate the model using the function. These are the model evaluates. First of all, we predict on the test set and then we evaluate the model. Here, using these functions, we extract future invariants and then we display the most important features using this vector function, 10 most important features. These are the 10 most important features. This is important 0. At last, we say these data set using these all functions. Here, in this case study, the custom information model built using random forest classifiers successfully classifies customers who are likely to churn based on key features such as usage patterns, demographics, and customer service interactions. By leveraging these predictive data, businesses can better understand the drivers of churn and take preventive actions to retain high-risk customers. Insights derived from the analysis empower companies to design targeted engagement strategies, thus reducing churn rates and enhancing our customer satisfaction. The render florist are all effective in handling complex databases and delivering variables results in these churn prediction tasks.